right, everybody, what's happening? I am sorry, first period, that I'm out today. It is the third Thursday of the month, and every third Thursday, I'm at a leadership conference all day long. So once again, I'm not just escaped to somewhere warm or sitting by a pool anywhere. I'm working, trying to become a better teacher, better coach, better everything. So I hope you did well in your quiz today. We've been practicing a lot. I was encouraged by the homeworks that I've seen, and I hope you felt okay about it. And now I'm going to do 2 short videos because I have to keep each of these under 15 minutes because I'm on the free trial of the website. But we're doing one final piece in this unit, and it's a little bit of a curveball. It doesn't involve graphs as much, but it's the last topic in the unit before we then start reviewing for our test. And it's a basic theme that you need to understand from a lot of different angles. And so we're going to try to hit it from 3 different angles, and it's the idea of an inverse function. Okay. So what is an inverse? I have this broken down into skills. So let's look at skill number 1. It's where you can find an inverse very informally. You don't really need a mathematical process, because what an inverse is you have a function, and then a function's inverse is that function that kind of undoes one another. And so what I mean by that is sometimes you can find the inverse of a function just by working backwards. To find its inverse. For example, find the inverse of the following functions by undoing the visible operation. Well, if our function is 6x, then that's 6 times x. So our inverse, I'll label it as g. No, I won't label it as g. Let's get used to writing the actual notation that it's supposed to be. The actual notation is f prime of x. It's kind of like the inverse. Okay? Sorry, I just shifted into calculus mode there. Wow, f prime. We're not ready for this yet. Our notation is to the -1 power. Okay, that is the annotation for inverse. So what's the inverse of 6x? Well, it's x divided by 6. Instead of 6 times x, it's x divided by 6. What about this next one? F of x is x divided by 4. Well, the inverse would be 4x. Instead of being divided by 4, you're being multiplied by 4. And then the last one, f of x equals 2x minus 3. That's 2 times x minus 3. Well, the inverse would be x plus 3 divided by 2. If you kind of say those operations out loud, you can see that they are kind of in reverse order. And not only reverse order, but they are inverse operations of one another. We had multiplication, we had division, we shifted to multiplication, so on and so forth. So sometimes it's as easy as just looking to find the inverse. But other times it's not. Okay? You can use your textbook if you have it, but I'm going to kind of break this down into 4 easy steps. And if it's a more complicated function where you can't just look at it and see what the inverse is, then here's what we're going to do. The first thing is we are going to use the horizontal line test to determine if an inverse exists. Okay, we're going to use a horizontal line test to determine if an inverse exists. If you have a graph like this one, we know what that guy is. It's a parabola. If you slice it through with a horizontal line and it hits more than one point, then this fails the horizontal line test, and this graph does not have an inverse. Okay? So if every function doesn't have an inverse, okay, but any function that passes the horizontal line test does have an inverse. So the first thing we need to do is give a little sketch and determine if it passes the horizontal line test. If it does, then here's the algebra that you use. Okay, you replace the f of x with a y, so that then you have it in terms of x and y, which honestly we're more used to dealing with that. Then you switch the x and the y, and you solve for y. We'll do an example here in a second. So if that doesn't make sense to you, you'll see what we're going to do in a second. We're just going to switch the x and y and then solve for y. Sorry, I have a phone call I needed to ignore. And then lastly, you're going to rewrite your final answer in inverse notation. That's not really a step, that's just more the way I want you to write your answer. So let's make sense of all this. Let's do an example. Okay, let's choose the top one to start. We got enough space. So we're looking at f of x equals 5 minus 3x over 2. Okay, use the vertical line test to determine if this graph has an inverse. Well, this is just an x to the power of 1, which means that this is just a linear graph. It's just a line, and a line passes the horizontal line test. So we're good. We do know that this function does have an inverse. So then what do my steps say? Step 2, replace the f of x with a y. Okay, I can do that. Y equals 5 minus 3x over 2. Then what's the next step say? Switch the x and y and solve for y. So what I'm going to do is I'm going to switch this. Notice how now the x is over here and the y is here. And then I'm going to undo these operations and get y by itself again. So I'm going to multiply by 2, which means I have to multiply that by 2. So I'm here. Then I'm going to subtract 5. So I'm at 2x minus 5 equals negative 3y. Get away, cat. And then I have to divide both sides by negative 3. And I'm probably just going to leave this like this. Ender, go away. Just say hello. Say hello. Get out of here. So my final answer is y equals 2x minus 5 divided by negative 3. That is my answer, but notice I want to write it as an inverse just so I can tell everybody what I found. So I would want to make sure I write it with this notation. This is my inverse of what we started with up here. So take a second and pause the video if you need to see how we started with a linear function. We switched the y in, we switched the x and y, then we resolved for y. So what we have is an inverse function, okay? And we'll talk about a way that we can test if two things are inverses later. I'm pretty sure we do that another day. Well, I want to go ahead and just tell you now, the way you can test if two things are inverses, so like if we wanted to test that those two are inverses, is we would put the inverse, which is this, and we would plug it in to that original function right there. And if they undo each other to where you just get left with one, like everything cancels out and you're just left with one, then you know that two functions are inverses. So it's kind of using what we did on the last test with f of g of x, where you put one function inside of another function. So hey, your algebra skills are not going away yet. All right, last thing before I finish video 1 is let's do this one. So we took care of the first one, boom. Let's do this one in green. Let's do this one next. So I'm going to write it over here. we have f of x equals square root of 2x minus 3. So we know this is a square root graph, so we know that it also passes the horizontal line test. So we know we're going to have an inverse. So now we can find it. So let's switch this in for a y. Then let's switch the x and the y. And now we got to solve backwards for y. So we have to make sure we do our order of operations correctly here. So I can't just add 3 over to the left because it's underneath the square root. What I need to first do is square both sides. Because now when we square both sides, we are now left with this. And now we can add 3, divide both sides by 2, and we have our inverse. But now let's put our thinking caps on here. And I can't believe I just said that. I'm turning into an old man. But seriously, what I mean is, like, let's make some connections. Can you imagine what this looks like in your head? It's going to be kind of just like a square root graph shifted to the right 3 and a little steeper than normal, so something like that. Can you imagine what this one would look like down here? That's an x squared graph. That looks like a u shifted up a little bit. So that would look like something like this. Those don't look exactly like opposites of each other. And it's because we're missing one piece. Because guess what? They would look like opposites of each other if you took away half of that parabola and if it only looked like that. Now you can kind of see, wait a minute, those kind of do look like they're related. Here's why. See how this function is underneath the square root? That means we have a restriction. That means that 2x minus 3 has to be greater than or equal to 0. And we have to solve that again for our domain. And x has to be greater than 3 over 2. So we have to include that in our domain to remind us that we can't have an x that's less than 3 over 2, or else we're going to get a negative underneath the square root. We cannot have negatives under the square root. So I guess I understand, or I'm reminded now why this inverses section comes last. It's because it uses pieces from every other thing that we did in this chapter. It uses the f of g of x idea. It uses our graphs. It uses the domain restrictions. It kind of uses everything and kind of ties it all together with one final thing. So, what is an inverse? An inverse, a function can have an inverse if the two functions kind of undo one another. Okay, if their operations are inverse operations. And the way you find it, if you can't find it just by looking at it for the easy ones, you find it by using these 4 steps. So I would definitely jot those down and note those. Because you will have problems on your homework that say, does this function have an inverse? If it does, go find it. So you'll have to be able to attack that. In the next video, I'm going to show you what an inverse looks like on the graph. I think this is going to, for you visual learners, that'll be a key thing to see. So make sure you don't jump straight to the homework. This next video will be shorter than the one that we just did. If you have questions, please jot them down, bring them to me on next class. I want this to be conversational when I get back so that we can make this idea of inverses kind of click, because it sometimes is tricky for students. So good luck. I miss you guys, and I will connect with you next week. Don't forget video number 2.